What does it take to break into data science? Which courses should you take? Which projects should you build? How long will this process take you? And what do you need to do to get your first data science job? In this video, we'll answer all these questions and much more. This is the 2023 Data Science Career Roadmap crafted with a lot of love and effort. We're glad to share it with you. Now you can learn all the required skills and you can build these portfolio projects and you can get a job in 6 to 9 months with just about 16 to 20 hours of effort per week. If you know these tools, you will be eligible to work at thousands of companies around the world in a data science role. As you go through this doc yourself, you will be able to expand each of these sections like I'm doing here. And we're going to go into each section and we're going to look at each individual skill. So the first skill you need to develop is programming with Python. Without programming, there is no data science role. And here are the sections within programming with Python that you should focus on. You should start by looking at variables, operators, and data types. And a Jupyter Notebook is a great place to start using online platforms like Jovian, Kaggle, or Google Colab. You can experiment with arithmetic, conditional, and logical operators in Python. And then you can also experiment with the different data types in Python, the primitive data types, numbers, strings, floats, and the compound container data types, lists, dictionaries, etc. So becoming familiar with these fundamentals is really important for you to be able to turn your thoughts into code. Now, once you know these building blocks, the next step is to learn about conditions, loops, and functions. You need to know how to perform branching with the if, elif, and else statements in Python. You need to know how to run loops, how to perform iteration with while loops and for loops. And you need to know how to use functions because functions are a great way to organize your code and make it reusable in different situations. So these are the qualities, these are the skills that people look for when they're testing your programming skills. Now, once you've learned these basics, you should practice a little bit of networking because in many cases, you will be downloading data from the internet and you can do that using the requests library in Python. And one other skill you can try to learn is web scraping, which is to extract a web page and then extract information from it and create a CSV file from it. Let's say you could try to scrape a particular category on Amazon.com and identify the product name, identify the product category, identify the product rating and price, and create a CSV out of it. This will enable you to quickly create data sets on whatever topic you need. So web scraping is a useful skill to have and is often tested in a lot of data science roles as well. Now, as you create projects, it's important that you improve the quality of your code, which means you use good variable names, which means you write explanations, you have comments within your code. And if you're using a Jupyter Notebook, you should be documenting your work using markdown cells, and you should be presenting and publishing your projects online. Any project that you work on is not complete unless you have documented it and published it online. And if you share the link of that project with somebody, they should be able to read it and understand what it does in 5 minutes based on your description, based on how you've organized it. So presenting and publishing your projects is also a very important skill. Otherwise, you have no way of providing evidence of what you've done. Next is solving programming challenges. Now, when you go out and apply for jobs, you will be given some programming challenges where you will have to solve some problems by writing code, and you will typically use things like lists and loops and conditions to solve these. One thing you should learn is how to find good practice problems on platforms like LeetCode, platforms like HackerRank, platforms like HackerEarth. And then you should also learn how to approach LeetCode problems the right way. So there are many ways to approach these problems, and the way to be productive is to try a problem for some time, then look up the solution if you're not able to solve it, and then put the solution away and try it yourself. And you have to solve a few dozen such problems to really get the hang of Python programming. Now, of course, as you try to solve these problems, you will face issues, and you have to learn how to debug these errors, how to fix the issues that you're facing. Now, once you feel confident about your Python programming skills, you should also try to develop some Python scripts locally on your computer. So you should set up your computer, install Python, install maybe the Anaconda package manager, and create a Python environment. Then you should create some Python scripts using an editor like Visual Studio Code, or you can also run Jupyter Notebooks on your computer, and you should be able to then run those within the environments that you've created on your computer. And finally, you should also learn how to use Git and GitHub, which is a version control system, to manage large Python projects and collaborate with other people. So that's about programming with Python. Now, once you've done this, or maybe even in parallel, you can also start learning SQL, the structured query language, and business intelligence tools. Most data that you will work with in the real world will be saved within a relational database. A relational database is one which contains tables and columns within, rows and columns within those tables, and relationships between tables. So you should learn how to set up MySQL or any other relational database on your computer, and how to create tables, how to issue commands, how to write queries. You should learn how to insert data and query data with SQL using the select statement, using the where clause, etc. You should learn about primary keys, foreign keys, references, aggregations, all the ways in which you set up a database and extract data and insert data into the database. So these are often called the CRUD operations: create, read, update, and delete. Once you've learned the basics of SQL, you should then go ahead and learn aggregation and joins with SQL. So you should be, for example, be able to count the number of rows satisfying a certain criteria, or group rows according to a certain column and then aggregate them, sum them up in some fashion as required. You should also learn how to combine data with SQL joins, and how to improve the performance of your SQL queries using indexes and views. Now, this is one of the most heavily tested skills when you're applying for jobs and when you're interviewing: aggregation, grouping, and combining data with joins. So make sure you get enough practice in these areas. Then an advanced topic in SQL is called window functions, where you can first partition a dataset into windows, and then you can run a function individually for each partition. And especially if you're applying for a job role which requires advanced usage of SQL, window functions are going to be important. So you should understand the syntax and the use cases of window functions, when they are relevant, when they are applicable, when they are not. You should understand the different ranking, aggregation, and value functions. And you should also understand a little bit of advanced windowing with rows and ranges and sliding windows and things like that. A few more advanced topics in SQL that may or may not be necessary. One is working with dates and strings. You should be able to extract different parts out of the date. You should be able to construct dates. You should be able to perform date arithmetic. And similarly, you should be able to combine strings and work with strings, create substrings and things like that. Apart from this, you should also learn about some advanced clauses and functions like the case clause, which can be used to create an if-else kind of a condition within a statement. And you should also learn about stored procedures and recursion in SQL. And this is a slightly more advanced concept. Again, may not show up necessarily in your job or even in interviews, but if you have the time, if you are digging into SQL, then it's worth looking into these areas as well. Now, apart from SQL, it's also important to learn Microsoft Excel, because as you are working in a company, you will interact with several stakeholders who will not be as technical as you are, and they will either give you data in the form of spreadsheets, or they will expect a spreadsheet as the output. So sometimes you may have to work with sheets, cells, formulas, and functions. Sometimes you may have to analyze and visualize data sets within Microsoft Excel. And of course, you may also want to make it presentable. You may want to do some styling. You may want to do some data validation. You may want to do some conditional formatting. You may want to create pivot tables and charts and things like that. And finally, you should learn some business intelligence tool like Tableau or Power BI for creating visualizations and dashboards. Typically, how this will work is you will connect a Tableau or Power BI instance to a SQL database, and you will fetch data from a SQL database. Maybe you'll write some queries to prepare the data first. And then once you fetch the data, you are going to build interactive charts, put multiple interactive charts and create a dashboard. And then you're going to publish that dashboard online. And that dashboard will show real-time data, and that will be accessible to other stakeholders within your company. A lot of companies are moving towards using Tableau or Power BI for creating these live dashboards. So I highly recommend learning this skill. Now, once you have these foundations in place, Python programming and SQL and business intelligence, then you might want to learn some of the core skills in data science. You would want to start with statistics for data science, and that's where I would recommend looking into probability. Probability includes things like coin tosses, dice rolls, playing cards, then looking at intersection, union of events, and independence between events, and possibly looking at topics like conditional probability and Bayes' theorem. I would focus on cultivating an intuitive understanding of probability. I would focus on understanding why the formulae work in the way they do. And then I would focus on trying to solve some probability puzzles and probability problems to prepare for interviews, because this is something that you will be tested on or something that you might be asked during an interview. Now, apart from probability, it's obviously important to learn about the measures of central tendency, things like mean, standard deviation, and variance. And you should be able to compute these metrics not just by working them out on paper, but using Python and its ecosystem of libraries like NumPy, SciPy, etc. Another topic is median, percentiles, quartiles, and range. Building box plots, understanding the distribution of data is very important. And again, it's important to get an intuitive feel of all of these, apart from, of course, how the median is calculated and the functions for it. Then the mode of a data set and frequency tables, and how to then use frequency tables to compute these statistics. All of these is something that you should also be familiar with. Also, things like growth rates, geometric means are also useful to know, especially for businesses. Now, you should also be familiar with some counting techniques, things like factorials, permutations, and combinations. And you should also be familiar with random variables, so discrete random variables and continuous random variables like the normal distribution, the probability distributions, and their expected values, their formulae. Not in the sense that you need to remember all the formulae, but you need to remember what the probability distributions for different types of random variables looks like, why they have such a distribution, and what each distribution can be interpreted as. You don't have to become an expert in solving problems and proving theorems here. You just need to have an intuitive understanding and understand the shapes of the graphs and what they are telling you, and understand how to identify which kind of a distribution data falls into by creating histograms and bar plots and things like that. Then one topic that you should be familiar with, this is not something that is covered in university or in high school, is hypothesis testing and statistical significance. Because especially in a lot of product companies, you perform a lot of experiments, and the way you evaluate experiments is by looking at data and computing whether the results are statistically significant. You will learn to state the null and alternate hypothesis when you learn this topic. You learn to compute z-scores and p-values, and you will learn to compare the significance and confidence levels to decide if the results of a particular experiment are statistically significant or not. You should solve a few problems, 5 to 10 problems on statistical significance, because this is something that you can expect to get tested on if this is something that you will be doing in your job. Finally, because you want to work at a product company and you want to apply your knowledge of statistics to help them improve their products, so you should understand the user journeys and the pirate funnel, the AAARRR funnel, which is acquisition, awareness, activation, retention, revenue, and referrals. So what does this pirate funnel mean? You should look up the term, and how does it apply to some case studies, and what do the different percentages for each pirate funnel's level of conversion mean, and how they can be increased, how they can be measured. All of this is something that you should be familiar with. Otherwise, you will miss a lot of the jargon when you're talking to an interviewer. And then you should also understand the key metrics that are used to measure each of the steps of the pirate funnel and the different tools that are used to measure these metrics. Now, one thing you also may want to know is how to improve products using data science and using machine learning, just at a very high level. Understanding what do recommendations mean, where can you apply machine learning techniques like supervised learning, unsupervised learning, clustering, regression, etc., so that you can have these conversations with non-technical stakeholders. So that's the third topic, statistics for data science. The next topic, and this is where you will actually spend 70 or 80% of your time as a data scientist or a data analyst, is data analysis and visualization. So this means you should be able to get data out of different kind of databases. You should be able to clean the data. You should be able to analyze and visualize the data and gather insights from the data. So the first thing you should start with is numerical computing with NumPy. You should learn about NumPy arrays, vectors, and matrices, and how they can be created in NumPy, how you can operate upon them in NumPy. You should experiment with the different kinds of array operations, the array methods, the slicing and broadcasting techniques in NumPy. Broadcasting and slicing are especially tricky to learn initially, but once you get the intuition for them, once you practice a little bit, they can be very powerful in helping you manipulate data and get the data that you want. Then you should learn how to read from and write to CSV files, because CSV files are the most common format in which you will receive data and the format in which you will export data as well. Once you've learned NumPy, you should then learn how to analyze tabular data using the pandas library. To begin, you should learn how to read a CSV file, how to query data from a CSV file, how to filter the data, and how to sort data frames. You can also do grouping and aggregation of data, and you can summarize the data, and you can gather insights by performing these summaries. And you should learn how to merge and join data from multiple sources, perform advanced forms of analysis, and then write that data back into a CSV file. Next, once you've learned a little bit of tabular data analysis, you should focus on visualization with Matplotlib and Seaborn. These are the two main libraries for visualization in Python. And you should learn to make basic visualizations with Matplotlib like line charts, bar charts, scatter plots. You can use Seaborn for more advanced visualization and for automatic data summarization. So you can create advanced scatter plots in Seaborn, you can create heat maps using Seaborn, you can create grids. You can also learn how to customize and style charts, which means making sure that they have proper axes, they have proper labels, they have proper marks on the axes, they have a proper legend, you're using good colors, you're using grids wherever required, you're using proper titles for the charts. All of this is really important in making your visualizations compelling, and all of this comes with a lot of practice. Next, you should focus on interactive visualization with Plotly and Folium. These may not be things that you use in your first job, so even if you're not spending too much time on these, that's probably fine, but you can create some really great interactive graphs using Plotly. You can add markers on these graphs, you can create 3D charts, and you can create animations using Plotly. And you can create geographical maps that people can zoom in and zoom out on, and you can create polygons, and you can mark out different areas, and you can create geographical heat maps using the Folium library. Now, once you've done that, you should then apply all these skills into exploratory data analysis by studying how somebody else has done it on another data set. And you can find loads of tutorials on these online, loads of examples, loads of videos. So here you will perform data preparation and cleaning with pandas, and then you will perform open-ended exploratory analysis and visualization. And finally, you will ask and answer interesting questions about the data. With this three-step process, of course, it's going to take 20 to 25 hours to actually do this on a large real-world data set. You will have learned how to use Python's ecosystem of libraries to gather insights from data and to answer questions about data. You may want to explore some advanced data analysis techniques, like how do you process large data sets which contain millions or maybe tens of millions of rows of data, maybe tens of gigabytes. And sometimes you may have to use tools like Dask and do some parallel processing so that these things fit within memory and can be processed within a reasonable amount of time. You should also learn how to work with categorical data, how you can encode categorical data in different forms, how you can use data type specific methods, how you can perform concatenation, merging, and joins using pandas and using some of the other tools that you can use for data analysis. Another important skill for you to learn, not in too much depth, but have just a good high level and practical understanding of, is machine learning. If you're targeting a data scientist job role, then machine learning becomes more important. And even for a data analyst role, it's good to have this as a skill set, because that will help you stand out when you put this on your resume. When you are appearing in interviews, you can talk a little bit about the work that you've done in machine learning. So you should start with linear regression using the scikit-learn library. You should understand how to perform linear regression with a single feature and with multiple features. You should understand how to use numeric and categorical features. You should understand how to interpret the regression coefficients and how to understand the importance of different features. Now, once you've learned linear regression, its close cousin is logistic regression for the purpose of classification, where you are trying not to predict a certain continuous value, but to classify inputs into multiple classes. Here, I would recommend that you should start working with real world data sets. So you should learn how to maybe download and process data sets from a website like Kaggle. Then you should train a scikit-learn logistic regression model. And then you should also learn how to create a validation set to evaluate the model and then make predictions on unseen data, and also save a trained model to the disk so that you can load it back later and use it when you need to. Now, once you've learned these two foundational algorithms, it's time to move on to tree-based methods. So you should learn how to work with decision trees and random forests. So you should learn how they work, what are the internal metrics that are used to decide splits within decision trees, what are the different parameters that are used to configure a random forest. So you should learn about overfitting. How do you look at the training loss, the validation loss, and determine whether your model is overfitting? You should learn about hyperparameter tuning. How can you change different parameters depending on the losses that you're getting? And finally, you should also focus on model interpretation. How do you interpret the results of these models, and how do you identify which features are important? Especially in some domains, you will be required to provide an explanation of why your model gives the result that it does. And if you do not understand how to interpret the models that you are building, then you will be at a loss completely, and you will not be a very effective machine learning practitioner. You should also think a little bit about the machine learning workflow, about how you translate a business problem, understand business needs, and build a machine learning problem statement. You should learn how to explore the data, look for hints that can help you build machine learning models effectively. You should prepare the data for modeling, create some features, perform some encoding, perform some scaling, perform some data imputing, and create baseline models before you actually go out and train machine learning models. And then finally, you can train some models, evaluate their performance, fine-tune them, and then combine multiple models to create an ensemble and get the best result possible. A slightly more advanced topic is gradient boosting. So, gradient boosting is a different way of combining decision trees to build machine learning models iteratively. So, here you can use a library like XGBoost. You can perform some data pre-processing, feature engineering, and then you can train some gradient boosting machines. You can evaluate the results and you can interpret the model's performance. You can also look into some areas like k-fold cross-validation, ensembling, stacking, hyperparameter tuning. So some advanced techniques to get the most out of your machine learning models and try to then apply it to some kind of a real world problem. And finally, you should have some understanding of some unsupervised learning algorithms, things like clustering and dimensionality reduction. Both of these are good ways for you to just understand your data without necessarily wanting to predict something about it. And then you have collaborative filtering and recommender systems. You don't have to become an expert at these, but you should know what these are. You should maybe have looked at a small example. You should have maybe worked on one small application of both of these. And then there are several other small machine learning techniques and algorithms that you can try to become familiar with, things like SVM, things like naive Bayes, a little bit of neural networks. But this is generally speaking sufficient or more than sufficient for your first data science job role. Now, once you've completed all of this, or maybe even when you're halfway into this process, you should start preparing to apply for jobs. Applying for jobs and cracking interviews is itself a skill, and that is itself something that requires preparation and conscious effort. So the first thing you should understand is how to research job roles. So you should try to understand where you are, what background you come from, what domain you're working in, how much work experience you have, and based on that, which are the right job roles for you to target. Should you be targeting a beginner level role? Should you be targeting a more advanced role? Should you be targeting a role in a specific domain because that's the domain you come from? Or can you apply in any domain? Really depends on your current life situation. Once you've identified which role you should target, which will typically be a data analyst or a junior data scientist role, you can research salaries, you can read about companies, you can understand what that job role will look like in terms of the job responsibilities and in terms of what you will make. This research is very important because otherwise you're likely to apply to the wrong kind of roles and you're likely to then get a lot of rejections and get demotivated. Now, once you've done that, you need to craft a job-winning resume. And the way to do that is not to list everything about yourself into a large doc. That is not a resume, that is a biography. First, you can write a bio just so that you have all that information to refer from. But then you should extract information about your education, about your work history into a one-page resume. Your resume should not go beyond one page. Because when you apply for a job, a recruiter or a potential employer is going to spend 10 seconds or less looking at your resume, and your resume needs to stand out in those 10 seconds. So that's where you also need to optimize the structure of your resume. You need to have just 3 or 4 sections: education, work experience, projects, and skills and certifications. And you need to highlight the right keywords. You need to talk about the sizes of the data sets of the projects that you've built and the kind of results that you've obtained and how you have succeeded in your past work experience or in your education. So your resume really needs to help you stand out. Now, one last thing you should also do is to customize your resume based on specific job roles. Now, just a resume is not sufficient. You should also work on improving your professional profiles, because any job that you apply to, people will be checking out your professional profiles like LinkedIn, GitHub, and you should link to these profiles from your resume. You should encourage people to check these out, and you should post regularly on these profiles to show that you have been learning data science continuously for the past several months. It's important to put your work up online. It's important to share your progress. That shows that you've made progress over time. That shows that you're interested in the domain. So you should also write blog posts, and you should share your work online, and you should improve and document and publish your projects, because your projects speak for you more than what you can speak for yourself in an interview. Your projects provide evidence of the kind of work that you will do in a company. So focus on going that extra mile on making your projects really good, making your projects really presentable and easy to understand. Now, you also need to prepare specifically for data science interviews, and for this you need to understand how employers shortlist and evaluate candidates. And then you need to prepare for non-technical questions, things like, tell me about yourself, why are you interested in this company, why are you interested in data science. These are questions you're going to get in every interview, but if you don't have prepared answers for these, then these are missed opportunities for you to make a case about why this company should hire you. And then, of course, you also need to prepare for technical interviews. So for Python programming, you need to practice a lot of problems on lead code. For SQL, you need to practice writing SQL queries. For statistics, you need to solve some problems. For data analysis and visualization, you need to review your projects carefully. Machine learning, you need to probably revise the theory, the intuition a little bit. And all of these things are things that you can do by spending
maybe 1 or 2 hours a day on preparation, but that 1 hour of preparation is really critical in helping you get that job. Now, in that time, while you're learning, while you're applying, you might also want to look for part-time and freelance work when you don't feel ready to jump in full-time, or you have been applying for some time but you're not hearing back. It might be a good idea to maybe get an internship. So you should know how to look for part-time work, and this is something that you can find on LinkedIn. This is something that you can find on websites like Angel List and Internshala. And you should learn how to write proposals, how to write cover letters, how to set expectations in terms of the work, and you should learn how to deliver great work and resolve conflicts when they come up, so that you can get a great recommendation for your part-time work, and that can help translate into full-time work. And of course, in this process, you will deal with a lot of rejection. So you also have to prepare yourself mentally, because you're going to get a lot of rejections, or you're just not going to hear back from a lot of companies because they receive so many applications for every job that they put out. Then you should also learn how to ask for and react to constructive feedback. You should also learn how to continue learning and continue improving your profile, and maybe also use your network of friends and colleagues and university network to maybe get referrals, maybe get feedback on your resume, maybe get some mock interview practice and things like that. Those are the 6 core skills that you should learn. And it's not enough to just learn these skills. You have to then build some projects to showcase these skills. And in fact, building projects is also the best way to consolidate your learning. So here are the 3 or 4 projects that you should build. The first project is a business intelligence dashboard. So here are some examples of the kind of dashboards that you can build. So here is a web traffic dashboard that somebody has created and put up on Tableau Public. You can find any dataset online, and then you can import it into Tableau Public, which is a free tool. And then you can build this kind of an interactive dashboard, and then you can publish this dashboard online. So check out some of the other examples given here for the projects that you should build. Similarly, the second project that you should build to showcase your Python and data analysis and visualization skills is EDA, or exploratory data analysis. Again, here is something that you can look at, a bunch of projects for you to look at. I'll open just one of these for you to see. So this is one project created by Vishnu, one of the participants in the Jovian Data Science Bootcamp, where he analyzed 120 years of Olympic Games data, and he performed this exploratory data analysis. So you can see that it's a fairly detailed project, where he started by creating an outline of the data set, downloading the data using Python, and then maybe setting up the color palette for Seaborn and Matplotlib, then performing some data preparation and performing some data cleaning, creating some graphs. So you can see here he's created various different types of graphs here, pie charts, bar charts, etc. Then he's also asked questions about the data set. For example, this word cloud, which shows which are the highest medal winning countries in the world. And here another pair plot showing relationships between different columns, and then bar plots, box plots, line charts, etc. You can see here this shows the count of participants in the Olympics from 1900 to 2020. So there are a few other projects here that you can explore. So I'll let you check these out. And then you can also check out some projects on classical machine learning with Python. So you should ideally get a data set from a Kaggle competition. Kaggle is a platform for data science competitions, and they have these historical data sets from competitions they've conducted in the past. You can download those data sets, you can build models on those data sets, and then you can publish your models, submit your predictions to Kaggle, and see where you would have stood if you're participating in the competition. And it's always a good idea to try to break into the top 30 or 40% of a Kaggle competition leaderboard. So here is an example. This is a project created by David, who was part of the Jovian Data Science Bootcamp, where he used the credit default payment prediction dataset from Kaggle. And he started by just downloading the data. And you can see also the level of presentation here, the level of work done in documenting the work. So he started by documenting the machine learning process, and then he did some data preparation, and he has various steps in the data preparation. Then he created some helper functions, and then finally went on to machine learning modeling, where he created some models, and then he trained those models. He trained decision trees, he trained random forests, and he tuned some hyperparameters, and finally he made some submissions to Kaggle, and he was able to get a great score on the Kaggle leaderboard, and he was able to break into the top 20% of the Kaggle leaderboard. So clearly, I'm hoping, looking at this project, you are feeling impressed by the amount of work that has gone into it and by the result that has been obtained. The kind of presentation as well, that is the reaction that potential employers and interviewers should have when they check out your projects. So do check out some of the other projects that we have listed here as well. And finally, if you're not into machine learning, if you want to target more of a data analyst role, then maybe you can check out a web scraping project where you can maybe scrape things like top rated movies from IMDb. So here you would use maybe something like the requests library or the Beautiful Soup library to download a web page and extract information. this is the page that we are scraping here, and from this page this is the information that we are extracting. And you can do this with any number of websites, any website that has a table or a list in some form. You can do this with sports website, you can do this with cryptocurrency websites, stocks data, with e-commerce websites, of course with movies and things like that. So these are the projects that you should build: business intelligence dashboard, exploratory data analysis, classical machine learning, web scraping. And apart from these, there are some optional skills that you can build. I would not recommend these skills for your first data science job, but if you're really interested in getting into a specific domain, let's say you want to do deep learning and you're 100% sure that's what you want to target, then you can focus a little more on deep learning with PyTorch or TensorFlow. And these are the topics that you can try and cover for deep learning. And similarly, you might want to focus a little bit on data structures and algorithms if you want to do a machine learning engineering kind of role where you are writing more code, you're building more software. Now, data structures and algorithms is not very important for a data scientist or data analyst role, but it can be important for a data engineer role or a machine learning engineer role. So these are the topics you may want to cover: binary search trees, sorting algorithms, divide and conquer, dynamic programming, graph algorithms, and just understanding how to crack Python coding interviews. And one more advanced area, an area that is really picking up right now with things like Chat GPT, is modern natural language processing. And here you can learn text classification using techniques like bag of words, TF-IDF, neural networks for natural language processing using PyTorch or TensorFlow, creating recurrent neural networks and creating embeddings, creating language models and generating text using transformers, using pre-trained models, using embeddings, and just understanding how some of the more advanced natural language processing models like Stable Diffusion, which generates images, or Chat GPT, which is a conversational bot, work. And along with these, you can also potentially look at optional projects in deep learning for computer vision, or natural language processing using deep learning, or web development and deployment. That's another useful skill that you can study, or machine learning model deployment. So we've linked to some example projects and tutorials here as well. But I want to stress again that these optional projects and optional skills are not something that you should focus on for getting your first data science job, unless you're very clear that there's a certain kind of role that you want to get into and you are well suited for that role. Typically because you already have domain experience in whatever domain that company operates in. Now, a few tips I want to share that will help you succeed in your learning journey. Keep these guidelines in mind. Focus on the skills that are required for your very first job. Don't try to learn everything. Data science is a vast domain and it is growing bigger every day. And there are more libraries that are coming up. There are more frameworks coming up. There are more models coming up. So that's what we've tried to focus on here. Focus on the recommended stuff. Focus on the recommended tools. You might have questions. Should I be learning R? Should I be learning reinforcement learning? Should I be learning this or that? Well, for your first role, this is what you should be learning. And find one good course or one good book for each topic. Now you can just take the topic title and search it online. You can find one good course. And we have introductory courses on many of these topics on Jovian that you can take for free. And of course, we have a data science bootcamp that you can also explore joining in case you want to dedicate yourself to this for the next 6 months. And try to set aside 20 hours per week and block your calendar. So go into your calendar, identify the 20 hours per week that you want to spend studying, and tell your friends, tell your family, tell your colleagues that you will not be available on these times because you're focusing on studying. Create a weekly plan of the topics you'll cover. So you want to have a plan of what you're going to do in a week. So spend 15 to 20 minutes just figuring out what you're going to learn, where you're going to learn from, how you're going to apply it, and what is the outcome that you're looking for by the end of the week. And then build projects for every topic you learn. Don't just learn something and then move on to the next topic. It's important that you consolidate your learning by building real world projects on large and unique data sets. We have webinars and videos about this on our YouTube channel, so you can subscribe if you want to learn more. Then make sure to document and publish your projects online. This is very important, and this is the most ignored part of learning data science, because when you go out and apply for jobs, you will have to showcase that you have these skills, especially if you don't come from this domain already. So that's where you need to have projects, and those projects need to be understandable. If it's just a bunch of code without any explanations, the project is useless, even if you've spent 100 hours on it. Spend that additional 5 to 10 hours to document your project and put it up online. And also find a study group to stay on track. Work together with a community. If you have 4 or 5 people who are all learning together, then that is going to motivate you. That is going to keep you on track. That is going to keep you from losing interest over time, because you might be excited. It's a new year. You're excited about data science. A lot of great things happening in AI, generative AI, deep learning, etc. But this excitement will not stay. So that's why you need to create systems, you need to create a schedule, you need to create a support network to stay motivated. Find a mentor if you can. Find somebody who is already working in the data science domain, probably a colleague, probably a senior, probably somebody you're related to, and talk to them every week, every month. Talk to them about your progress, talk to them about what's working, what's not working, get their feedback on your resume, get their feedback on your projects and how you can improve, get the feedback on the type of jobs that you should apply for. And finally, also try to get referrals for job roles from your network, because when you apply to job listings available online, there are hundreds of people who apply and your resume may never even get seen. But if somebody vouches for you, somebody gives you a reference, somebody directly puts your resume in front of an interviewer, in front of a recruiter or a hiring manager, that increases your chances of getting hired by 10x. So referrals are very useful, very important. Now, all of these things are obviously hard to do, and all these things take time, take discipline, take a lot of motivation. So, if you want to enter a structured program where we have dedicated support and mentorship and a large community of people who are helping each other out, then you should consider joining the Jovian Data Science Bootcamp. And the roadmap that I just showed you is the roadmap that we have built by experimenting over the last year and a half with different topics, with different skills within those topics, with different orders in which you should learn things. And this is what we've come up with because this is what is working for the most number of people. If you do want to explore the Jovian Data Science Bootcamp, this is what the structure looks like. It's a 6-month part-time program. You spend about 20 hours per week, where in the weeks 1 to 8, you focus on learning programming with Python and SQL and Business Intelligence, all the topics that I just showed you. And then you have 5 practical assignments to practice these skills. And then you spend a couple of weeks building the project on a business intelligence dashboard. Then for the weeks 9 to 16, so 2 more months, you focus on data analysis and visualization, and you also learn statistics for data science, solve 5 practical assignments, coding assignments, and then you build your second project on exploratory data analysis. And you have dedicated support throughout. So whenever you're stuck, you need help, you can get support over chat, you can get support over one-on-one calls, and we give you detailed feedback on your projects. We tell you how you should document them, how you should put them up online. So the projects that you just looked at, that is the kind of projects that you will be building. And in fact, you will have the opportunity to look at hundreds of projects from Jovian alumni, and you will then be able to build your projects, which are at least as good, if not better, than most of the projects that have already been put out there. And your projects will really stand out when you put them on your resume or when you apply for job roles. And finally, the last 2 months are spent on learning machine learning, where you learn the foundations of machine learning, apply it to real world data sets, and work towards building a machine learning project, but also on career readiness training. So every aspect that I talk about, identifying which job role you should target, we provide one-on-one guidance, one-on-one mentorship, because we have a limited program. We just accept about 40 to 50 students every month. We also then work with you on your resume. We work on LinkedIn, GitHub, etc. And then we also have a large set of quizzes and a large set of interview preparation material that you have access to. We also have unlimited mock interviews for you so that you can prepare, you can make all the mistakes that you're possibly going to make within these mock interviews. And then we also have a network of 200 plus hiring partners. So we put your resume directly in front of the companies. You don't have to go through the normal application process where they look at hundreds of resumes. They just look at 2 or 3 resumes and they choose among Jovian graduates. And we have a large and growing network of hiring partners. So a lot of the challenges that you might face when you are learning on your own are things that we've tried to address in the Jovian Data Science Bootcamp. So people always ask me, what is the difference between taking some free courses or joining a program like Jovian? This is the difference. You can do all of this on your own. You have great resources available online. You have great books, you have great courses, but just staying motivated, this is a long journey. Having the support, having the guidance, having the mentorship, and having the industry connections, having the alumni network, the community, all of that is something that is very important in helping you succeed. Apart from, of course, the technical material, which if you've taken any of our courses, I'm sure you must have really enjoyed the practical approach that we take in our courses as well. So that's the data science career roadmap. I know that you're looking to get into data science, so I hope that you find these things helpful. And one thing I want to add here is we have introductory courses on a lot of these topics. So if you just head over to jovian.ai/learn, so we have a bunch of free courses. We have the Data Science Bootcamp, but we also have a bunch of free courses that you can get started with just to get a taste of what it is like to learn data science and to learn on Jovian. So we have the Data analysis with Python 0 to Pandas course. 72,000 people have taken this course and we've had great reviews. We have courses on deep learning. We have a course on natural language processing. So you have courses here, and of course you have a lot of tutorials on YouTube elsewhere as well. So whatever you're doing, just make sure that you have a focus on what you're going to learn, what you're going to build. So tie it to an outcome of getting a job and work backwards from there to figure out. Otherwise, this can be an endless journey of just learning and learning and learning, but never actually applying or never actually making that career transition.
With that, I hope you're ready to get started on your data science journey. If you found this video helpful, hit the like button and check out other videos on our channel for data science tips and tutorials. I'll see you next time.